the oscillator. So now we are heading towards the phase to calculate the phase difference between the applied force and the displacement. As you know, the applied force was F is equal to F naught e raised to power iota omega t. Okay, so the reactive part now we are taking because it causes a phase difference. Suppose it is causing the phase difference phi between the applied force and the displacement. So we have simply replaced R by Zm cos phi, and this which was further known as Xm. So this was the basically reactance. So Zxm is equal to Zm sin phi. So from here Zm would be Zm could be written like this, and R when replaced with the Zm cos phi, and this term when replaced with Zm sin phi. So we are taking Zm outside, we are taking common. So cos phi plus iota sin phi would again go to e raised to power iota phi. So here Zm is Zm e raised to power iota phi. So here Zm is the real part and this is the imaginary part. And the magnitude of the Zm would be given like this is, suppose this is p plus iota q and p square plus q square under root. So Zm square cos square phi plus Zm square sin square phi whole raised to power 1 by 2. So this Zm is the magnitude of the complex mechanical impedance. Over the whole, this Zm is complex, but this is the magnitude of that function. And phi is taken as because to calculate the value of phi we would need to divide these both equation. So sin phi by cos phi would give you tan phi. So this would be equal to Zm here you can see this Zm sin phi by Zm cos phi, and this is written as omega m minus s by omega, and this is by r, this is xm by n. So it means that you can see on the this is known as the Aragon diagram. Basically the real axis is there and the imaginary axis is there, and this is r, and this is your xm, this value is your xm, and this is your Zm or the complex function. So now we are going to substitute the value of Zm. Arrow is written over here because this basically depicts the complex part. So you can see that x was equal to a e raised to power iota omega t, and a would have been replaced by minus iota f naught upon omega Zm e raised to power iota omega t. And now we have calculated the value of Zm in terms of phi. So we are just substituting the value of Zm over here. So Zm was equal to Zm e raised to power iota phi. Okay. So from this whole thing we are, because we are just adding the e powers. So e raised to power iota omega t minus iota phi. So this would give you iota omega t minus phi. So we are left with this x. Okay. So when we are opening this e raised to power function, so when we are opening this e raised to power function, so we are getting here minus iota f naught upon omega Zm cos omega t minus phi plus iota sin omega t minus phi, because we are taking this as a cis theta, cos theta plus iota sin theta. Okay, so this I have been taking this, and then after because iota has been taken inside, so now we are getting minus f naught upon omega Zm iota cos omega t minus phi, and here also because of iota and iota would multiply to give you minus 1. So minus sine of omega t minus phi. So you can see that when we are multiplying iota inside, so the real part would basically change to imaginary part, and the imaginary part would change to the real part. So we were talking that applied force is F is equal to F naught e raised to power iota omega t. So this could be written as F naught cos of omega t minus iota sine of, here plus is there, plus iota sine omega t. So you can write it f naught cos of omega t plus iota f naught sine of omega t. So real part is f naught cos omega t. So here you can see the real part is basically containing the term sine. Okay, so this part is corresponding to f is equal to f naught cos omega t, and this part cos function is basically considering is basically corresponding to f naught sine omega t. So sine omega t plus minus phi, because sine theta is basically equal to cos theta minus pi by 2. So when we are converting sine to cos, we will write here omega t minus phi by 2. Okay, so you can see that this here omega t is there, and here we can see that phi minus phi by 2. So what it means that the total phase difference between the driving force and the displacement is minus phi plus pi by 2. So what it means, x is lagging behind the f by this much of phase. So this is the phase difference, and all the mathematical analysis we have carried out just now.